come back to our today's lecture. As in the last period, we have seen the most important article of this particular chapter, and now the today's outline of the lecture is compound pendulum, center of suspension and center of oscillation, interchangeability of center of suspension and center of oscillation. Next one is the advantages of compound pendulum, and then we will go to the one example of compound pendulum, that is Scatter's pendulum. Now, if you remember our last period, that is yesterday's period, we have seen that simple pendulum is one of the device which is used to determine the value of G, that is acceleration due to gravity. The simple pendulum is consisting of a thread. One end of the thread is fixed to the rigid support, while to the other end a bob is attached. The bob is displaced from its mean position. Then the pendulum oscillates on the both sides of its mean position. We will count the oscillations at a particular time. We will measure the length of the pendulum from the center of suspension to the bob, that is the that is the length of the pendulum. As the oscillations performed by this simple pendulum are simple harmonic in nature, then by using the formula T is equals to 2 pi under root L upon G, we can determine the value of G, that is the acceleration due to gravity. This method to determine the value of G is the simplest, easy method that can be used in the laboratory and also at home. But in addition to that one, we have also seen that this method of determining the value of G by using the simple pendulum has some disadvantages. There are some drawbacks of the simple pendulum, and what are these drawbacks we have seen yesterday. And now to overcome the drawbacks of the simple pendulum in determining the value of G, that is acceleration due to gravity, the another type of pendulum has come into the existence, or another type of pendulum is used, and that pendulum is called as compound pendulum. The compound pendulum is also called as physical pendulum, or sometimes it is also called as rigid pendulum. Now, what is the basic difference between the compound pendulum and simple pendulum? The basic difference in compound pendulum and simple pendulum is that compound pendulum is just a rigid body. वहां पर धागा और बाप दोनों मिला के थे सिंपल पेंडुलम में. यहाँ पर ऐसा धागा बाप दो अलग अलग बॉडीज नहीं रहेंगे, बल्कि पूरी की पूरी एक लंबी बॉडी रहेंगी. हाँ, वो कोई भी किसी भी शक्ल की या किसी भी शेप की हो, वो बात दिगर है. That means there is a rigid body, isn't it? There is a rigid body, whatever may be of shape, and this body कैसी होना? This body is capable of oscillating about the horizontal axis passing through it. कोई भी बॉडी हो, अगर वो उसका कोई भी शेप हो, लेकिन अगर वो एक हॉरिजॉन्टल एक्सिस के दरमियान ऐसी अगर घूम सकती होंगी ऐसी, तो सच टाइप ऑफ ए बॉडी इट इज कॉल्ड एज कंपाउंड पेंडुलम. पेंडुलम के वास्ते उन्हें ऐसा घूमना जरूरी है. किसके अतराफ घूमना? ए एक्सिस पासिंग थ्रू इट्स सेंटर, और इट इज कैपेबल ऑफ ऑसिलेटिंग हॉरिजॉन्टली अबाउट एन एक्सिस पासिंग थ्रू इट. अगर उस बॉडी में समझो ये बॉडी है, उसमें से ऐसे एक्सिस डाले और वो बॉडी एक्सिस के तरफ ऐसा अगर घूमती होंगी, तो दैट बॉडी इज कॉल्ड एज what anybody unmute and tell me. Pathan Faizan, Khazi Tasneem, Mahvish, Ansari, are you getting or not? All of you are getting me, please? That is called as compound pendulum.
सर आवाज नहीं आ रही आपकी.
आ रही है अब आवाज?
Yes.
Yes. So may I repeat once again? So what I have told you, that a pendulum, compound pendulum, is just a body which is capable of oscillating freely about an axis, passing through its center or passing through it. It is called as a compound pendulum. Now, please unmute anybody of you and please tell me which type of differentiation or difference you are observing in simple pendulum and in compound pendulum. Are you getting? मेरी आवाज आ रही है?
Yes, sir.
Can you tell me what is the difference between the simple pendulum and compound pendulum? In case of simple pendulum, there was a thread and a bob. These two combines together and it is suspended to the rigid support, that is called as simple pendulum. But in that case, there is no thread, no bob, but an entire body is there. पूरी की पूरी लोहे की, प्लास्टिक की, लकड़ी की जो भी होगी, पूरी एक बॉडी रहेगी, entire body, rigid body रहेगी, and that body is कैसी रहना, लेकिन that body should be capable of oscillating about an horizontal axis, passing through it. Then that body will work as a pendulum, and that pendulum is called as which type of pendulum? Please unmute and tell me.
Compound.
Compound pendulum. So difference between the simple pendulum and compound pendulum is that simple pendulum is consisting of two parts. One is thread and another is bob. एक धागा और धागे के दूसरे सिरे को एक छोटी सी गोटी बंधी हुई, दोनों को मिला के अगर लटका दिए रिजिड सपोर्ट से, खुलाबे से, कील से, नौक से, और वो जब अगर घूम रहा तो डेट इज कॉल्ड एज सिंपल पेंडुलम. And that method of simple pendulum to determine the value of G has some drawbacks that we have seen yesterday. And that's why in order to overcome the drawbacks, in order to remove the drawbacks or defaults of the simple pendulum, another type of pendulum has come into existence, or another type of pendulum it is used, and that pendulum it is called as compound pendulum. Isn't it got you, Tanvir? And the compound pendulum is a body, it is a rigid body, whatever it may be the shape कौन सा भी हो सकता. वहां पे पहले क्या था, धागा और बॉब जरूरी थे, यहाँ पे धागा और बॉब ऐसा कुछ जरूरी नहीं, कौन सी भी शक्ल की, कौन सी भी शेप की बॉडी रहना, खाली क्या रहना, वो रिजिड बॉडी रहना, और वो रिजिड बॉडी किसी कील को, किसी खुलाबे को लटका के ये पोजीशन में रहना कि वो अपनी हॉरिजॉन्टल एक्सिस पर ऐसा क्या कर सके, ऑसिलेट कर सके. Then such a body is called as what? Tell me. It is called as compound pendulum, isn't it? The point at which the vertical plane passing through the center of gravity of the pendulum meets, it is called as the axis of rotation. जब ये बॉडी ऐसी रहेंगी तो उसको क्या बोलेंगे? The point at which the vertical plane passing through the center of gravity, this one, यहाँ से जो लाइन सेंटर में से जो लाइन पास होंगी, it is called as axis of rotation, isn't it? And the center of it is, जिसके ऊपर उसको लटका देंगे ये पॉइंट को, जिसके ऊपर उसे टंगाया जाएगा आम अल्फाज में, that point is called as the center of suspension. That means the point at which the body is suspended, that point is called as center of suspension, or sometimes you may call it the point of suspension. और दूसरा हिस्सा जिसके अतराफ वो लटकेगी, जहां पर उसका center of gravity होगा, that is called as center of oscillation, isn't it? In its normal position to its rest, that means this position here, G is the center of gravity, it lies below the center of suspension. इसका जो ग्रेविटी है, सेंटर ऑफ ग्रेविटी या पॉइंट ऑफ ग्रेविटी किसके नीचे रहेगा?
Point of suspension.
Yes, point of suspension के नीचे. So if you see the sequence, center of suspension is at the top, center of gravity is in the middle, and below the center of gravity there is a center of oscillation in which it is moving. Center of suspension fix रहेगा, हिलेगा नहीं. Center of gravity उसके बीच में रहेगी, क्योंकि किसको भी center रहता, और उसके नीचे center of gravity के नीचे जो हिस्सा हिलेगा ऐसा, that will be called as center of oscillation, or you may call that point as the point of oscillation. Have you understand?
Yes, sir.
So let
Yes,
us,
sir.
yes. So Alhamdulillah, let's go to this figure. In this figure, let us consider that there is a pendulum, that is a compound pendulum of any shape. देखिए मैंने बड़ा बेतरतीब शेप लिया है, कोई भी शेप का रह सकता, isn't it? Now this body, which is a rigid body, it is suspended at the point S with the help of the rigid support. Therefore, the point S is the center of suspension. Am I correct? Now, below the center of suspension, there is a center of gravity, that is G, isn't it? That is G. Now, weight of the pendulum. What happened now? The center of gravity, when the pendulum is displaced, अब क्या करें, आपको पहले ये पोजीशन पर है, वो यहाँ पर है ये. अब आपने G को ऐसा अपने हाथ में पकड़े और ऐसा यूं ले गए, छोड़ दिए. तो जब आप G को उठा के G डैश पे लेकर जाते, तो पूरा के पूरा ये घूम के कहाँ जाता? यस G क्या बन जाता? यस G डैश. Am I correct? And
Yes,
with
sir.
the horizontal, there is a triangle is formed like this. Which triangle? G, yes, G dash. This triangle is formed. Can you observe the triangle on your screen, please?
Yes, sir.
And this is the theta, which it is the displacement. Theta is this the angular displacement. ऐसा गोल जा रहा ना यूं. So theta is the angular displacement. And this center of gravity in the displaced position comes from G to G dash, isn't it? And this line, yes, G dash, this one, distance between the center of suspension and center of gravity, it is called as length of the pendulum. यहाँ पर length of the pendulum किसको बोलेंगे? Distance between center of suspension and center of gravity. And this line, when the center of gravity is shift from G to G in the displaced position, then this distance, yes, G dash, it is denoted as L, and it is what? It is the length of pendulum. Have you got?
Yes, sir.
Now when it is displaced, come in the G dash position, the weight of the pendulum, it is always directed at the downward. किसी भी चीज का वजन किधर काम करता है हमेशा? ऊपर की तरफ कि नीचे की तरफ?
नीचे की तरफ.
नीचे की तरफ. That means the weight of the pendulum is mg, mass into g, acceleration due to gravity, and it is always directed vertically downward at G dash, and therefore its reaction at the point of suspension, yes, constitute the couple. उसका वजन नीचे की तरफ काम कर रहा, आप उसको उठा के इधर लेके जा रहे है क्या नहीं? समझ में आ रही बात? आपने हाथ में पकड़े, इधर झूला लिए ना ऐसा यूं, इधर झूला ले जाने की वजह से उसका वेट भी है वहां, आप इधर लेके जा रहे, तो एट ए टाइम कितने वेट उसके, कितने कुव्वत उसके ऊपर काम कर रही, कितने फोर्सेस? एक तो आपके टू फोर्सेस, यानी कि एक तो आपकी ले गई हुई और दूसरा उसका खुद का वजन. Am I correct? And as a result of these two forces acting on the pendulum simultaneously, but in opposite direction, it constitute a couple on it. लिहाजा जब दो कुव्वतें बेक वक्त किसी जिस्म पर काम कर रही हो और उन दो कुव्वतों की डायरेक्शन अलग अलग हो, तो वो किसको जन्म देती है? पढ़ के आए आप. When there are the two forces having the same magnitude in opposite direction, form a couple. Have idea about the couple? Please tell me. Mahek, do you know what is couple? मेरी आवाज आ रही है? Are you getting me, please?
Yes, sir. आ रही है.
So can you tell me what is couple? Couple means a force of combination of the two forces acting on the body simultaneously. Now when the pendulum is displaced from SG to SG dash, then at this position SG dash, two types of forces are acting on the pendulum, and therefore these two forces give rise to or constitute a couple. Couple को दूसरा क्या नाम है जी तनवीर? क्या नाम है कपल को? दूसरा टार्क भी बोलते कपल को. It is called as torque. So that means a torque is developed there, or couple is developed there, isn't it? And that developed couple, that developed torque tries to bring the pendulum towards its mean position. आप उसको ऐसा लेके जा रहे हैं, लेकिन खुद ब खुद उसके अंदर जो टार्क पैदा हो रही वो उसको क्या करती है, उसके मीन पोजीशन पे ला. ऐसा करने के बाद उधर ही चले जाता. कब तक वैसा रुक जाता?
नहीं.
रुकता कैसे? नहीं,
नहीं सर.
वापस आ जाता. तो इसको वापस लाने के लिए कौन जिम्मेदार है? The weight of the pendulum, this couple which is formed here is responsible to bring the pendulum towards its original position. ऐसा होने के बाद उसकी वो जो उसके अंदर जो टार्क पैदा होती वो उसको दोबारा लेकर आती अपने मीन पोजीशन पे, इधर लेके जाती. इधर जाने के बाद फिर दूसरी टार्क वहां काम करती, वो इसको इधर लेके जाती. Isn't it? That means the torque which is formed here is acting as a restoring couple. Restoring couple means the couple which acts on the pendulum tries to bring it towards its mean position. वो ऐसी कुव्वत जो उसके अंदर पैदा हुई है और उसके मीन पोजीशन को लाने की कोशिश करती है. रिस्टोरिंग, रिस्टोर के माने कैसा है? दोबारा हासिल करना. रिस्टोरिंग के लफ्जी माने क्या है? दोबारा मीन पोजीशन पे लाने की कोशिश करती है. Isn't it? The weight of the pendulum acting vertically downward at the G dash and its reaction at the point of suspension, yes, constitute a couple or torque, and this couple is tending to bring the pendulum towards its mean position. And therefore, the moment of this force, it is given by force into displacement. Moment of force समझता आपको? Moment of force is given by लगने वाली force into distance or angle. Now here the moment of this restoring couple is force. Force कितनी लगी? mgl. mg उसका weight, l उसकी length, यानी कि लेंथ यल लंबाई का धागा या लंबाई की बॉडी का वजन कितना होगा? वो mgl. Now this much is force is acting on sin theta. That means in this triangle sin theta अगर निकाले तो क्या होगा जी? This one, this into mgl. So the restoring couple, moment of this restoring couple is mgl sin theta, but with minus sign. Why? फोर्स तो कभी निगेटिव नहीं रहती, लेकिन माइनस क्यों आया है?
Opposite.
Yes, that means you are displacing the pendulum towards different direction.
Opposite direction.
Yes, it is due to the opposite direction that negative sign has oriented to this one, isn't it? And therefore, if the moment of inertia of if small capital I is the moment, अब ये बॉडी क्या कर रही? रोटेट कर रही है ऐसा, और जो बॉडी रोटेट करती है उसको मोमेंट ऑफ इनर्शिया लगा हुआ रहता. Do you know the term moment of inertia?
Yes.
Yes,
Yes, sir.
moment of inertia, Jamut, it is called as Jamut ka Meari asar. And therefore, if this body is rotating, therefore it possesses the moment of inertia I. If theta is the angular displacement, what is velocity? D theta by dt. What is acceleration? d2 theta by dt square. Am I correct?
Yes.
Isn't it? And therefore is I is the moment of inertia. d2 theta by dt square is the angular acceleration. So the couple is equal to I d2 theta by dt square. जो couple इसके ऊपर काम करेगी वो कितनी रहेंगी? उसका moment of inertia into angular moment, angular acceleration. That is the couple acting on that particular pendulum at this position. It is equals to I into d2 theta by dt square, where I is the moment of inertia and d2 theta by dt square is
Angular
angular acceleration. And therefore, and this is the force acting. This is the force acting on that one, no doubt. But this force acting, it is but due to this force, it comes to here. And this force, it is equal to mgl sin theta. इतना जो ये I d2 theta by dt square उसके ऊपर लग रहा, लेकिन it is in equilibrium. And that force is equal to the total force acting on that one, that is restoring couple. Restoring couple कितनी है?
minus
D2
mgl sin theta. इसका मतलब I d2 theta by dt square, it should be equal to mgl sin theta.
sin
theta.
Isn't it? Therefore, I d2 theta by dt square is equals to minus mgl sin theta. once again using this our trigonometry कि displacement थोड़ा है, बड़ा इतना जोर से दूर नहीं ले जा रहे, बल्कि if theta is small, sin theta is approximately equal to theta, and therefore instead of writing this I d2 theta by dt square minus mgl theta, can I write like that? Instead of sin theta, can I write theta? So I d2 theta by dt square is equal to minus mgl theta. Now I want d2 theta by dt square from this equation. So I will take I towards this right hand side. When it comes to the right hand side, it will come in denominator. Therefore, d2 theta by dt square is equal to minus mgl upon I into theta. I have taken in the bracket sign. Can you tell me why reason of taking this quantity into the bracket? Because all this bracketed quantity is constant. M, mass, constant. Small g, constant.
Constant.
L, constant. I, constant. Therefore, it is entire is constant. It is d2 theta by dt square is equal to minus mu theta, a constant. Suppose instead of this entire bracketed quantity, I have taken mu. Therefore, mgl upon I is equals to mu. That is acceleration per unit displacement, and therefore pendulum executes. लिहाजा ये इक्वेशन कैसी बन गई जी? अब d2 theta by dt square, ये this minus will goes to the mu theta is equals to 0, and what is ये काय की इक्वेशन हो गई फिर? d2 theta by dt square plus mu theta is equals to 0. Yesterday I have told you that this is the differential equation of a motion of this pendulum. और अगर इक्वेशन ऑफ मोशन ये इक्वेशन परफॉर्म करती तो कौन सी किस्म की मोशन होगी पेंडुलम की? Simple
harmonic motion.
And that's so from this one, after having this equation d2 theta by dt square is equal to mu theta is equals to 0, from having this equation for the motion of our pendulum, we come to the conclusion that this our compound pendulum performs simple harmonic motion. Am I correct? And if the motion of the pendulum is simple harmonic, its time period is given by the formula t is equals to 2 pi under root this 1 upon mu, yani कि L upon G. That means this one. Now 2 pi, this L upon G, all this one. So this is the required expression for the time period of the compound pendulum. If I is 0 is the moment of inertia of the pendulum about an axis passing through the center of gravity, G parallel to the axis, that is दो सेंटर है समझो, S में से पास हो रहा और एक G में से पास हो रहा, दो ऐसे है तो दोनों एक्सिस कैसे हो गए? पैरेलल हो गए. So now we will apply the principle of parallel axis, and for the principle of parallel axis, moment of inertia is I is equals to I0 plus ml square. कहाँ से आया जी ये? I is equals to I0 ml square. This has come from your 12th standard chapter number 3, I think, of 4, moment of inertia, in which you have seen the two principle of perpendicular axis and principle of parallel axis. Do you remember that one? So from that,
Yes, sir.
from that one, this I is equals to I0 plus ml square has come, and therefore we can see here this I is equals to mk square plus ml square. Now this mk is the moment of radius of gyration. K is radius of gyration. Do you know the definition of radius of gyration? Again the same chapter, moment of inertia. In Urdu, it is calling as gardishi nisqutar. Anybody of you is in a position to tell me what is the radius of gyration? आप में से कोई है जो मुझे बता सकता है कि रेडियस ऑफ गायरेशन किसको बोलते? When a body it is rotating, any color of the body is there and it is rotating. Now I will try to show here. Suppose any body is there, it is of this type, isn't it? Now this body is rotating about this axis. Am I correct? Can you see my figure which I am drawing?
Yes, sir.
Now this is the one point, this is another point, because this body is made up of large number of particles. Am I correct? These,
Yes,
all
sir.
these are points of this one. Now this is the axis of rotation. Now this is suppose point number 1. The mass of this point is m1, suppose, isn't it? m1. Getting? Now
M2 दूसरे point का.
yes, now the distance of this point 1 from the center of rotation, axis of rotation, this is the axis of rotation ना, ऐसी फिर रही ना बॉडी इसके अतराफ. आप घर में भी
हाँ.
एक्सपेरिमेंट कर सकते हैं. आपके बैंगल है ना छुरी, बैंगल छुरी हाथमी की,
हाँ.
उसके बीच में ऐसे कुल्फी की लकड़ी बांध दो और उसके तरफ फिरा, उसको फिरता कि नहीं ऐसा फिरेंगे. तो ये क्या हो गया, एक्सिस ऑफ रोटेशन. So now this point P, this point which is having the mass m1 is at a distance of suppose small r1. कितने दूरी पर है सेंटर ऑफ सस्पेंशन एक्सिस ऑफ रोटेशन से m1 की दूरी पर. ये सपोज दिस इज द पार्टिकल नंबर 2 having the mass m2. This point is suppose at the distance of r2. समझ आया? तीसरा पॉइंट at a distance of r3.
याद आया.
Isn't it? And therefore लेकिन ये सब पॉइंट का एक ऐसा पॉइंट रहता जो सेंटर में रहता, डेट इज कॉल्ड एज द सेंटर ऑफ ग्रेविटी. नाउ द रेडियस ऑफ गायरेशन इज द डिस्टेंस बिटवीन द एक्सिस ऑफ रोटेशन एंड द पॉइंट at which the entire mass of the body is supposed to be concentrated as to possess the same moment of inertia. That is called as radius of gyration.
Variation.
Radius of gyration, G-Y-R-A-T-I-O-N. Do you remember now?
Yes, sir.
And that is denoted by the symbol K. And for that one, we are having the formula. That means I0 is equal to mk, I0 is plus ml square, therefore I0 is equal to mk square, and therefore I is equals to, from that one you can see, it is I is equals to mk square plus ml square is equal to mk square plus l square, isn't it? And therefore T is equals to 2 pi under root m bracket में k square plus l square upon mgl. This is the required expression for the time period of the compound pendulum, isn't it? Therefore 2 as it is, ये m कट गया, therefore k square plus l square upon gl, and that means using this equation, is it possible for you to determine the value of g from this equation? इसको अगर हमने स्क्वायर करे तो t square is equal to 4 pi square k square upon l plus 1 divided by g. And using this equation, you can determine the moment of inertia. You can determine the acceleration due to gravity using which pendulum?
Simple pendulum.
Compound pendulum. Using the compound pendulum, isn't it? So with this one, this article is. Have you got this article? Have you got?
Yes.
दूसरा आर्टिकल लियूं. Now just you have seen that pendulum is suspended at one point. That point is called as the center of suspension. Pendulum is suspended. Now in between this one, there is a one point on the body of itself at which the whole mass is concentrated. That is called as the center of gravity. Am I correct? Distance between center of gravity and the center of suspension, it is called as length of pendulum. Below the center of gravity, at some distance, there is another point which oscillates, and that point is called as what?
Oscillation point.
Center of
Oscillation.
oscillation. Isn't it? Distance between center of oscillation and center of gravity is k square upon L is equals to L dash. Isn't it?
Yes.
And this overall order is center of suspension, उससे अच्छे खासे डिस्टेंस के बाद सेंटर ऑफ ग्रेविटी, और उससे कम डिस्टेंस के ऊपर सेंटर ऑफ oscillation. Distance between center of oscillation and center of gravity is k square upon L is equals to small l, isn't it? And therefore the previous formula can be written as T is equals to 2 pi under root, using this one
L upon G.
Yes, k square upon L is equals to SG. This is SG equal to L. Therefore, total SO कितना होगा जी? SG plus GO. SG कितना है? L. GO is
K square upon L.
the entire is constant and this is L. That is the entire length of the pendulum. That is capital L. यानी कि total length तो capital L रहेंगी pendulum की, लेकिन उसमें का काम वाला कितना रहेगा खाली? This one. That is called as the length of the pendulum. And therefore T is equals to 2 pi under root L upon G. This is the time period of the pendulum, isn't it? Now, one more article I would like to share with you: interchangeability of center of suspension and center of oscillation. Now this is the center of suspension, this is center of gravity, and this is center of oscillation. Now it is suspended about this one, time period is obtained, suppose it is equals to t, isn't it? Now I taken the pendulum from center of suspension and invert it, उल्टा कर दिए, उल्टा दिए, उल्टा के क्या करे, सेंटर ऑफ ऑसिलेशन को सेंटर ऑफ सस्पेंशन बनाए और सेंटर ऑफ सस्पेंशन को सेंटर ऑफ ऑसिलेशन बनाए. Again time period is measured for the 30 oscillation suppose, and during this time, if the time period for about the S and time period about the O is found to be same, it means that center of suspension and center of oscillations are interchangeable. क्या मतलब हुआ? यहाँ पे कहीं जब आपके हाथ में बॉडी दी गई एक सिंपल, तो वहां पे कोई ऐसी तमीज थी क्या कि भाई इसके अतराफ ही लटकाना या इसके अतराफ ही लटकाना?
नहीं.
तो आप किसी के भी अतराफ लटका सकते थे. तो सेंटर ऑफ सस्पेंशन कैन बिकम द सेंटर ऑफ ऑसिलेशन एंड सेंटर ऑफ ऑसिलेशन कैन बिकम द सेंटर ऑफ
Oscillation.
यानी कि सेंटर ऑफ सस्पेंशन ऑसिलेशन बन सकता है और सेंटर ऑफ ऑसिलेशन सेंटर ऑफ सस्पेंशन बन सकता है.
Suspension.
लेकिन कब बनेगा? When it is possible practically, when the time period of the pendulum about S or about O, it should be equal to same for both one. यानी कि दोनों के भी अतराफ टाइम पीरियड कैसा आना? The time period should be the same. If it is happening, then the time period of the pendulum about S and O is same. Then what we can say? उस वक्त हम उसको क्या बोलेंगे?
Interchangeability.
Yes. Center of suspension and center of oscillations are interchangeable. Now please tell me, such interchangeability is possible in case of simple pendulum? Is it possible?
Yes, sir.
Simple
Yes, sir.
pendulum.
Yes.
Simple pendulum में possible है?
Yes, sir.
Yes, sir. Possible है.
Possible है. Simple pendulum में possible है. Center of suspension और center of oscillation एक बन सकता. कौन है वहां पे center of oscillation? बॉब है ना वहां
सर वहाँ पे
पॉसिबल था वहां पर. सिंपल
वहाँ पर
पेंडुलम
बॉब
में
है तो
बॉब के अतराफ लटका सकते थे और नीचे धागा छोड़ सकते थे.
नो सर.
No, sir.
So that means center of suspension and center of oscillation, this is interchangeability is possible only in case of
compound
pendulum. So that means
Compound
in case
pendulum.
of the compound pendulum, interchangeability of center of suspension and center of oscillation is possible. Have you got?
Yes, sir.
So this is called as the center interchangeability. Have you got this idea now? This is the same thing I have told you. Advantages of compound pendulum. क्या एडवांटेज है? वहां जो ड्रॉबैक थे वो यहाँ हट जाएंगे पूरे. Errors due to the finite weight of the string and its extensibility are limited. वहां धागा था तो उसकी हाइट कम ज्यादा होती थी. मैंने बोला था हवा से धागा ऐसा ऐसा भी करता, यूं होता यूं होता. ये बॉडी होंगी जो पूरी की पूरी बॉडी हवा से आधी इधर आधी उधर नहीं.
नहीं सर.
तो फाइनाइट वेट है, इनएक्सटेंसिबल है, देयरफॉर वो एरर कम हो गया. देन अनसर्टेनिटी इन द मोशन ऑफ द बॉब इज एब्सेंट, कि भाई बॉब भी अपने एक्सिस पर रोटेट करता था. यहाँ तो बॉब का सवाल ही नहीं, पूरी की पूरी अखंड बॉडी है यहाँ. एम आई करेक्ट?
Yes,
Yes,
sir.
sir.
That is also avoid here. Due to the larger mass of the body, viscous force due to the air have negligible. क्योंकि बॉडी की मास ज्यादा है, इस वास्ते हवा की वजह से इधर उधर आएगा वो पार्ट. विस्कस फोर्स बोले तो अपोज करने वाली मोशन अगर ऐसी है और हवा चढ़ी तो इधर जाएगा, ऐसा होता है. वहां जाता था, है क्या नहीं? तो यहाँ पे वो पॉसिबल नहीं है. Error due to the finite amplitude of the saving and yielding the support can also be determined by the correction applied to them. Equivalent length of the simple pendulum in these cases can also be determined. That means in short, if I told you that whatever the drawbacks of the simple pendulum were there, they can be removed, and therefore that is the advantage of
Compound pendulum.
Compound pendulum.
isn't it? And with this one, this is also over. One more article is remaining from this particular chapter. Time is now over. Ketter's pendulum. Ketter's pendulum किसकी एग्जाम्पल है? चार्ट में अगर 2 मिनट में मैं बता दूं आपको, इट इज एग्जाम्पल ऑफ कंपाउंड पेंडुलम. इट इज ए लॉन्ग यूनिफॉर्म मेटालिक रॉड. इसका प्रैक्टिकल भी है हमको, इसलिए तेजी से निकल जाता हूँ. पहले इसके ऊपर लटकाने का, इसके ऊपर वेट्स वगैरह रहते हैं. एनीवे टाइम इज नॉट परमिटिंग, So we shall stop here today. Remaining thing we shall see in the next period. Now within 1.5 minutes, if you want to ask any question, you may please ask. Now I will put in the chat box the link for the today's presentee and absentee. You are requested to send the feedback on this particular topic, your attendance, isn't it? You have to show. So anyway, we shall stop here today. In the next period, probably on Monday or next year, I will try to see the Keter's pendulum. So thank you for joining me. Remaining thing we shall see. Please ask to the other to attend the periods regularly. It will create the problem to those who are not coming to the period, isn't it? So thank you for
Yes, sir.
joining me. Have a nice time ahead. We shall stop here. Remaining thing we shall see.